Good evening, everyone. We are we are honored to begin today's first session with our expert speaker, Professor Dr. Vaibhav Magdum sir, on topic Smart Mobility Revolution: Role of AI and ML in Sustainable Electric Vehicles. Before we begin our first session, let us have a brief introduction of our today's first speaker. Dr. Vaibhav Magdum sir is an accomplished academician and researcher in electrical engineering with over 20 years of teaching and academic experience. He is currently serving as an associate of professor in the Department of Electrical Engineering at DKT Society Textile and Engineering Institute, Ichalkaranji. Dr. Magdum holds PhD in electrical engineering and has completed his ME in electrical power system and BE in electrical engineering from reputed institutions in Pune. His areas of expertise include power system, electrical machines, instrumentation, smart grids, electrical and hybrid vehicles, energy conservation, and optimization techniques. A prolific contributor to research, he has published more than 40 papers in international journals, presented papers at international and national conferences, holds patents in battery management system and AI-based surveillance, and has actively participated in more than 75 AICTE approved FDPs, workshops, and training programs. He has also received multiple Best Teacher Awards and professional recognitions, making him a highly knowledgeable and industry relevant expert speaker. With this, I hand over this mic Professor Dr. V.V. Magdum sir and to start the session. Magdum sir.
Okay. Thank you very much, madam, for this brief introduction. Dear participants, before starting with my session, as a coordinator, I would like to share with you a few instructions that we have to follow according to the ATAL Academy. As far as ATAL Academy is concerned, they are being providing certain regulations and instructions for the participants for successful completion and certification. So let me first introduce you to those instructions. First and foremost thing is to ensure the smooth conduct and maximum benefit from the online ATAL Faculty Development Program FDP. All participants are requested to kindly follow those instructions. First and foremost thing is all the participants must complete their registration using the official ATAL portal. The daily attendance will be monitored through online attendance logged in the Microsoft Teams platform. As we are using the Microsoft Teams platform, we will be having the attendance sheet directly that can be downloaded based on the timing through which the attendees are attending that particular session. Further, a minimum of 80% attendance as per the AICTE guidelines is mandatory to receive the certificate. So all the participants must have at least 80% attendance among these 6 days. Further, you have to join the sessions within the time because official meeting link will be shared according to the organizers and only single meeting link is shared to you. While joining, just take a care that you are joining with your full name as registered on the ATAL portal, as because we are taking the attendance directly from the Teams itself. So proper name registration at the time of joining the Teams is mandatory. Further, you can either use the chat box or raise your hand, and you can ask queries or questions during the interactions. Further, participants are required to submit the feedback form online test as a part of the FDP requirement. As far as considered, on the day 6, that is on Saturday, 10th January, we will be conducting an online test assessment, and in that MCQ test assessment, as per the ATAL guidelines, the participant must score more than 70% marks. Okay, and that is mandatory. Further, the participant must submit the final feedback form, which is compulsory on the ATAL portal. As well as a part of this particular ATAL FDP, we as organizers will be sharing one single feedback form on the 6th day of this particular ATAL FDP. So total 2 feedback you have to fill, one directly on the ATAL portal and one that is been shared by the organizers on the WhatsApp group. The certificate shall be issued to those participants who are registered on the ATAL portal, attend the program with minimum 80% attendance, score minimum 70% marks in the test, and complete the online feedback on the ATAL portal. So these all criteria has to be fulfilled to get the certificates. Further, whatever important announcements, links and updates will be there, that will be shared accordingly on the WhatsApp groups, and participants are required to check their messages regularly. So with this, I could say that we all request the participants to follow these few instructions to make the FDP a successful and enriching learning experience for everyone. And best wishes for the productive and engaging online ATAL FDP. So after this, I will be sharing my next screen, in which I will be discussing on my first topic. So please give me 1 minute. Okay, I hope the screen is visible to all the participants. So, as a part of day 1, session 1, as a keynote address, I will be discussing on a topic, smart mobility revolution, a role of artificial intelligence and machine learning in sustainable electric vehicles. So, good evening to all the respected participants, faculty members. It's a privilege to be here today for this faculty development program on a topic that truly defines the future of engineering education and research, as this topic sits at the intersection of technology, sustainability, and education. The idea here is smart mobility revolution, role of artificial intelligence and machine learning in sustainable electrical vehicles. I first of all would like to thank the ATAL Academy AICT for selecting our theme that bridges two powerful revolutions happening simultaneously. The first is the electrification revolution, which is fundamentally changing how the vehicles are powered, moving away from fossil fuels towards the cleaner electrical energy. The electrification revolution reshaping how we move, the electrical revolution which aims to reduce fossil fuels dependency and the emission. While the second revolution, what we can say, is the intelligence revolution, where machines are no longer just executing the commands, but learning from data, predicting the outcomes, and supporting the decision making. The intelligence revolution redefines how we think, how we design, and optimize. The intelligence revolution introduces the data driven decision making into engineering systems. So we are going to bridge these two revolutions to one another, and we will come out with a smart outcomes. Furthermore, in our next hour, I would like to take you on a journey from the global sustainability challenges to the algorithms that can power the next generation of clean, smart mobility solutions. We will also discuss how our academic ecosystem, our courses, laboratories, and the research can evolve to lead this transformation. We will start with why sustainable mobility is necessary, then explore how artificial intelligence and machine learning enables it, and finally we will discuss what role we as the faculty members can play through our curriculum, through the laboratories and our research work. So as we can say, the global perspective why sustainability and sustainable mobility is required. Our global mobility systems are at crucial turning point right now. As we can say, let us first understand why this topic matters globally. As we say, the transportation is one of the largest contributors to greenhouse gas emission globally, accounting for nearly about 1/4, means we can say about 25% of the total CO2 emissions are through these transportations. In densely populated urban regions such as metro cities like Delhi, Mumbai, Pune, etc., the vehicular emission directly affects the air quality, public health, and climate resilience. The electrification is a crucial step towards cleaner mobility, but it is not a complete solution by itself. If we say that the electric vehicles adoption increases without any intelligence, now it may happen that new problems may emerge. For example, if we say uncontrolled charging during the peak hours can overload the power grids, forcing the utilities to rely on fossil fuels based peaking plants. And hence, we have to say that the real solution lies in smart, sustainable, and integrated mobility, where electrical vehicles are connected to the grid infrastructure and users through the data driven intelligence. Artificial intelligence enables the forecasting, optimization, and real time decision making, ensuring that the electrification actually leads to the sustainability. So, what challenges we can say is that the paradox will be, we can say, unmanaged EV adoption can shift the problem and will not solve it. Means what? Suppose if we consider that if millions of the electrical vehicles charge randomly during the peak hours, we will simply shift the pollution from the tailpipe to the power plant. Because so as to charge all these electric vehicles at the same time, large amount of electricity will be required to be generated, and for that whatever fossil fuels that are being used for the generation, that will be used more, and again they are going to cause the same emission and pollution. So what are the challenges we can say? First and foremost thing is, we can say, is about the battery cost and the degradation of the batteries. So we can say that battery packs contribute up to about 40% of electrical vehicle cost. The degradation over time reduces the driving range and increases the replacement cost of these batteries, discouraging the adoption of these battery vehicles. The high cost and the limited lifespan remains barriers to the widespread electrical vehicle adoption. That is one of the challenge. Another challenge what we can say in adoption of the electric vehicles is that limited charging infrastructure. That is, scarcity of the charging infrastructure or unevenly distributed charging stations reduce the consumer confidence and the convenience of the charging. Especially for long distance travel, we can say it is inconvenient to have the EVs. Insufficient charging networks hinders electrical vehicles convenience and the accessibility. That is the second challenge. The third challenge what we can say is grid instability during the peak hours. Simultaneously charging can cause the voltage fluctuations, frequency deviations, and transformer overloading. Peak load charging threatens the power grid stability and the efficiency. So that will be a third challenge what we can say. Moving further, the fourth challenge what we have is lack of intelligence and intelligent energy management. That is, without artificial intelligence, energy usage remains reactive rather than predictive and optimized. So lack of intelligent systems for optimizing the energy use and the distribution is the fourth challenge what we can say. And finally, one more challenge what we have is the need for skilled professionals with interdisciplinary knowledge. The electrical vehicle sector requires the engineers skilled in power electronics, data science, artificial intelligence, control system, and sustainability. An interdisciplinary challenge is one of the key part in this particular EV adoption. So need for interdisciplinary knowledge combining the electrical vehicle technology along with the artificial intelligence and machine learning expertise is very needed nowadays. And hence we can say we must combine the engineering with intelligence. So as a solution, what we can say, artificial intelligence plus the electrical vehicles gives us the output as sustainable mobility. And hence integrating AI and EV technology is not optional but is more essential for achieving true sustainable mobility. That is what we can say here. Moving further, let us understand now artificial intelligence and machine learning in the electric vehicle context. So what we can say is artificial intelligence and machine learning are the catalysts that transforms the electric vehicle data into actionable intelligence. So let us begin with some clarity. As we are well aware, what is artificial intelligence? It is, we can say in short, the ability of the machines to learn, reason, and make decisions like humans. Artificial intelligence refers to systems capable of reasoning, learning, and decision making, mimicking certain aspects of human intelligence. Machine learning, a subset of artificial intelligence, focuses on algorithms that learn from a data to make certain predictions and certain decisions without being explicitly programmed. Furthermore, the second part what we have is the machine learning. And what is machine learning? We can say is the algorithms that learn the patterns from the data and make predictions or decisions. Now, in case of electric vehicles, EVs, the data is abundant. That is, the data comes from various different sensors, GPS, BMS, battery management system, motors, controllers, and users also. So here, in this case, artificial intelligence, machine learning converts their data into insight and the action. Artificial intelligence in electric vehicle ecosystem includes various different things. One of them, what we can say, is the smart battery management. Second is predictive maintenance. Third is energy optimization. Fourth is smart charging and grid integration. And the fifth one, route and traffic intelligence. So artificial intelligence and machine learning transform this raw data into actionable insights, enabling predictive, adaptive, and autonomous operation. The electric vehicle artificial intelligence ecosystem includes smart battery management, predictive maintenance, energy optimization, intelligent charging, and traffic aware routing, each of which contributes directly to the efficiency, safety, and sustainability. So let's look at each area more deeply now. So as we say, artificial intelligence in battery design and management. What is the role of artificial intelligence in battery design and management? If we say here, artificial intelligence transforms the battery from a simpler power source into an intelligent asset. The battery is the heart of an EV and also the costliest component we can say. The battery is the most critical and expensive component in an electric vehicle. Artificial intelligence significantly enhances the battery performance across its life cycle. So, as a part of the application of artificial intelligence, we can come out with certain more applications in this battery design and battery management. The first thing what we can say is the battery materials discovery. Now, here in this case, machine learning accelerates the discovery of new electrodes and electrolyte materials by predicting the properties of those materials such as energy density, thermal stability, and degradation rates, reducing the years of laboratory experimentation. Using the machine learning models to predict the energy density, stability, and degradation of the new components, we can take a help of the machine learning algorithms and certain AI applications. For example, if we say Google and Stanford used machine learning to identify the battery lifetimes, which are 9 times faster than the lab testing. So whatever time that is been consumed in the laboratories, that is going to reduce with a large scale. Next to that, we can use different artificial intelligence applications and machine learning algorithms to check the state of health as well as the state of charge. So machine learning models such as support vector regression, neural networks, Gaussian processes can estimate the state of health as well as the state of charge with high accuracy for different kinds of batteries. Third application what we can do for by using artificial intelligence and machine learning is adaptive charging. Means what? Artificial intelligence learns from the past charging cycles to determine the optimal charging curves which prolongs the battery life. Artificial intelligence optimizes the charging profiles based on the historical usage and preventing the overcharging and minimizes the degradation of the cells and the batteries. And furthermore, one more thing what we can do is the thermal management of these batteries by using AI/ML models. So what we can say here is artificial intelligence regulates the cooling system dynamically based on the driving patterns and environmental temperature. So depending on what kind of driving patterns are there and what is the environmental temperature, the artificial intelligence will take the feedbacks from these and accordingly regulate the cooling system, which will help the overall battery life to improve. So as we can say, the outcome of these all is longer battery life, higher safety, and sustainable resource use. So in this way, artificial intelligence and machine learning will help us in overall efficient operation of the battery in case of design as well as battery management. Moving further, as here we can say, next is vehicle dynamics and powertrain optimization. Here, artificial intelligence optimizes every watt of the power from the powertrain. The second brain of the electric vehicle lies in its powertrain. The combination of electric motor, controller, and the inverter can be considered to be as a powertrain, and the powertrain is the operational core of an electrical vehicle. Here in this case, the artificial intelligence enables intelligent control of motors, inverters, and the energy flow between batteries, motors, and controllers. Here in this case, the artificial intelligence and machine learning will help us by using reinforcement learning. That is, it will determine optimal torque and the speed control for the minimal power loss. Second, this AI/ML will help us for model predictive control, which will combine with artificial intelligence and it will ensure the real-time adaptation to the driving conditions. Further, this AI/ML will help us for smart regenerative braking. Here in this case, the artificial intelligence will predict when to harvest the kinetic energy efficiently. Smart regenerative braking systems predict the braking opportunities, maximizing the energy recovery without compromising the safety or comfort. So here we can say the real world implementations have shown significant improvements in vehicle range and efficiency through AI based optimization. As an example, we can say here Tesla uses the deep learning to optimize the energy efficiency per route and the driver behavior, achieving up to about 15 to 20% better range. So that is the real-time data that has been taken from the Tesla. So this is how the artificial intelligence will help us to improve the dynamics as well as the powertrain optimization. Moving further, the next thing what we can say is about the maintenance and diagnostics. Here we can say For these electric vehicles, for all the sections of these electric vehicles, the maintenance is very important. Moreover, the predictive maintenance and diagnosis is also very important. So we can say here that the traditional maintenance is reactive, which fixes after the failure, but artificial intelligence makes it predictive, that is, it will fix before failure. Means what happens is, in the traditional maintenance strategies, why we call it as a reactive and inefficient is because once the failure takes place, after the failure of a particular system or a component, we go for the maintenance. But here, when we are using the artificial intelligence techniques, we will transfer this maintenance into a predictive process wherein we can fix a particular issue before its failure. So that will help us to improve the overall efficiency and life of that all the components. The key tools what we can say here is the sensor fusion. That is, the sensors will take the data from various different components like vibration, torque, temperature data, etc. Further, the anomaly detection will take place using the machine learning techniques like SVM, random forest, etc. And finally, it will be processed through the cloud analytics dashboards. Actions will be taken accordingly so that whatever issues or problems that are present in this can be taken care of immediately, and there will not be any issue or any burden that can shut down, or whatever total downtime of that particular EV will be there, that will be reduced. So what we can say as a benefits, first and foremost benefit is the downtime will be reduced by about 40 to 50% because we are predicting a particular failure before it is going to take place. Further, the reliability and the safety will be improved to a higher level, and the overall life cycle cost, what we can say, will be lower, and the cost will be lower, but the overall life of that particular components will be more. Thus, we can say, in short, that by analyzing the various different parameters, that is vibration, temperature, current, torque, data, etc., the machine learning models detects the early signs of component failure. The cloud-based dashboards provides the real-time diagnostics and the alerts. And the benefits what we can have is the reduced downtime, improved safety, and the lower total ownership cost. For academia, this domain offers a rich opportunities for the research, simulation, and industry collaboration. So this particular area offers rich research background, predictive models, IoT data logging, and simulation-based studies can be done. So those who are having a research based can go for all these things, and they have large opportunities in for the research in this particular area. Now moving further, the next thing what we can say is in case of smart charging and grid integration. Here we can say smart charging transforms a fleet of electric vehicles from the grid burden into an grid asset. Means what? As said earlier, when suppose hundreds of EVs plugs in simultaneously, the grid will face a stress, and here to avoid that overall stress on the grid, artificial intelligence will help when, where, and how much charging should occur. The uncoordinated electric vehicle charging can destabilize the power grids. Here in artificial intelligence will enable the intelligent charging, which will help us to reduce the overall burden on the grid. So here the artificial intelligence applications will help us in various different things. First and foremost is the demand forecasting. Means what? The AI techniques will predict the peak loads, and using the machine learning regressions models, they will check what is the demand and they will forecast what is the demand. Further, next application what we can use for the AI is the dynamic pricing. Here in this case we can say dynamic pricing will help us to adjust the charging cost to spread the demand evenly. Next to that, the AI application will be help us to vehicle to grid, that is electrical vehicles will return the power to the grid during the high demand hours. Next, artificial intelligence applications we can use in the clustering algorithms like k-means, group charging stations by usage patterns. And one more thing what we can do is AI application will help us in reinforcement learning. That is, it will determine the optimal charging times to minimize the total cost and the maximize and it will help us to maximize the renewable usage. So overall, the demand forecasting models will predict the load patterns, while dynamic pricing incentives, off-peak charging, vehicle to grid technology allows electric vehicles to act as a distributed energy storage units, and clustering and reinforcement learning algorithms will optimize the charging schedules, maximize the renewable energy utilization, and overall reduction in the cost will take place. So as a result, we can say efficient grid use, renewable energy integration, and carbon foot reduction will be achieved by using AI and ML applications while doing a smart charging with grid integration. So this will largely help us to reduce the overall burden on the grid, as well as it will help us to efficiently use the available power as and when it required and where it is required. So that is the outcome of the AI/ML in charging and grid integration. Moving further, this AI/ML will further help us in other applications like smart mobility and traffic systems. Here we can say the intelligence extends beyond the vehicle to the entire urban mobility ecosystem. Why? Because here we can say that mobility is not just about the cars, it's about the ecosystem of the roads, signals, and the cities. Mobility extends beyond the vehicles to include roads, signals, and urban infrastructure. Now, in this particular area, artificial intelligence and machine learning algorithms will help us to improve various different things. First and foremost thing is about the route optimization. If we use the machine learning models, they will predict the traffic congestion and suggest the energy efficient patterns. Means if on a particular road there is a traffic congestion, they will give us alert which will make a particular transitor or driver to en route to the another path, so that he will reduce the overall traffic congestion and the overall energy efficiency can be achieved. Second thing is intelligent traffic control. That is, here whatever machine learning algorithms are there, based on those signal systems, whatever traffic controls are there, that will be adapted and the real time monitoring can be done depending on the overall traffic, and signals can be implemented. Further, fleet management is there. That is, artificial intelligence will coordinate the delivery of fleets to minimize the travel distance. And finally, one more thing what we can take a help of AI and ML to improve the smart parking. That means it will predict the overall space that is available in the real time, and it will suggest a particular driver where the parking slots are available, and accordingly he can have a efficient battery optimization, because he will not go on searching the particular charging point and parking point, and here the time consumption will be also less. So it will help to reduce the overall time in the transit also. So thus we can say artificial intelligence powered route optimization reduces the congestion and energy consumption. Intelligent traffic signals adapts in real time using reinforcement learning. The fleet management systems will minimize the total travel distance, while smart parking solutions will reduce the idle driving. So these all things are going to get benefited by adapting the artificial intelligence and machine learning models. Thus, we can say these systems will collectively enhance the overall urban efficiency. They will obviously help us to reduce the emissions, and further they will also help us to improve the quality of life. So one of the example what I can give here is Singapore's smart mobility initiative uses the artificial intelligence to cut the congestion by about 20% and reduce the travel time by about 15%. So nowadays, whatever AIML algorithms that are being used in the Singapore, that has given the overall result which has reduced the congestion and the overall travel time, that is by 20% and 15% respectively. So obviously, by adopting artificial intelligence machine learning, we can also take the help of these algorithms for smart mobility in traffic system, and the overall ecosystem within the city can be improved. Moving further, now we all being a faculty of the technical education, we can say that we can integrate these artificial intelligence and machine learning in our academics. That is, now let's discuss how we as a faculty can integrate these technologies into teaching and the research. As we can say, we as a faculty play a pivotal role in preparing future engineers. Artificial intelligence and electric vehicle concepts can be integrated through specialized courses or the laboratories or projects and the capstone works. Academia must architect the future of intelligent mobility. The challenges and the opportunities what we have discussed right now requires a new generation of engineers. As the educators and the researchers, we are uniquely positioned to build a talent and knowledge base that will drive this transformation. And obviously, we can take certain steps to improve all these things. What we can do is, there are different things what we can do. One thing is we can modernize the curriculum. First thing that is one thing. Second thing what we can do is the foster research, and the third one is build infrastructure. So we being a faculty, we can introduce these all things and we can come out with the good results. So talking on this particular point, we can say that we as a faculty can view the artificial intelligence and machine learning directly into our core curriculum and laboratories. So what we can do, we can adapt different things. One of them is the curriculum ideas. Under the curriculum ideas, we can have a new course that is which is based on artificial intelligence for sustainable mobility, which will include the different topics based on artificial intelligence and sustainable mobility, how these are going to help us in overall energy efficiency improvement and cost reduction. Further, we can take a help of a lab module. One of the lab module example what we can have is a battery data analytics with using the different programming methods. One of them is Python. So using these lab models, we can analyze the different data of that battery, and we can improve the overall life of that battery, and the charging and discharging patterns can be analyzed by using different programming methods in the laboratory sessions. Furthermore, we can have a project, we can provide different ideas of the projects to the students, in which the example what we can say is machine learning based EV charging predictors, which will use a particular data set of the earlier charging patterns, and it will predict how the charging of the particular battery will take place, how the time consuming will be there, and how the battery will efficiently get charged, and all these things can be done under the project. And further, as a capstone work, we can say reinforcement learning for energy efficiency. So these things are a few of the examples that we can adapt in our curriculum as a curriculum ideas. One more thing what we can do as a faculty is about the improvement in the infrastructure. What we can have is build artificial intelligence EV laboratories with the battery test beds and the sensors. We can establish the interdisciplinary collaborations between the various departments like electrical engineering, computer science and engineering, mechanical engineering, civil engineering, etc. These all students will come out with their ideas and in collaboration with each other can improve the overall structure of the EVs right now by adapting certain new ideas from the artificial intelligence and machine learning algorithms. And further, we can encourage the joint publications and the FDP collaborations. So these are a few of the things what we can do in our uh, core curriculum and laboratory sessions. Further, as a tip, we can say start small, use open data sets from Kaggle, EV battery repositories, or simulation tools like MATLAB, Simulink, etc., plus Python machine learning libraries. We can use all these things and we can come out with new discoveries. Further, we can say that interdisciplinary collaboration across the various departments, as I said, electrical, mechanical, computer science, and civil engineering departments is very, very essential nowadays because the open data sets and simulation tools will enable the low cost, high impact implementation. So this is one of the idea what I have to share to the faculties. So as to have all these things to be adapted, there are certain things are to be done. First and foremost thing is the institutional roadmap is one of the things that is required here. So as a part of this institutional roadmap, certain steps that an institute or the university can take, first and foremost thing is establish a center for artificial intelligence and sustainable mobility to act as a hub of research and innovation. The second thing what we can do as a step is develop MOUs with EV startups and OEMs for the real world data access and the internships. Further, as a third step, we can do apply for the AICT, DST for the grants on the artificial intelligence mobility themes. Next step, what we can do is build local data sets and open repositories to foster a collaborative research community. And one more thing, what we can do is host the student hackathons focused on artificial intelligence and EV combination applications to encourage the creativity and attract the talent. If there are certain things more than that that can also be adapted. Now when these steps are being taken by the institutes or universities as such, overall impact or the results we can get, what we can have is it will create the institutional visibility, drive industry partnerships, and unlock the new funding opportunities. So adapting all these steps, we can obviously improve the talent. We can come out with the students who are having a talent in the various different fields, and all these can be taken to care of for the implementation, which will obviously help us to improve the overall energy efficiency and the life and sustainability. Moving further, as a case study, we can say a smart campus EV project, how it will be. Imagine that suppose we are having a institute or a university, and in our university or a institute we are having 10 EV shuttles, and you deploy artificial intelligence in that particular part. So what we can have here is we can predict the battery health to schedule the maintenance proactively. We can optimize the shuttle routes based on the class schedules and using the solar panel energy availability. Further, we can manage the charging to occur during off-peak hours and the low-cost hours. Further, what quantifiable results we are going to get? We can predict that within a year, we can have the results in such a way that 25% reduction in the campus energy cost will take place, about 15% less vehicle downtime, and students will obviously gain invaluable real world experience. So we can say a smart campus EV system serves as a real world laboratory, artificial intelligence driven optimization of routes, charging and maintenance leads to cost saving, reduced downtime and experimental students learning. This model mirrors smart city ecosystems at a manageable scale. This becomes a living laboratory. That is what we can say a part of a smart city. So this is one of the case study what we can imagine, and we can get a results according to the implementation strategies that we can have. That is a combination of AI, ML, EV with cooperation and collaboration with one another. Moving further, what responsibility we have, and responsible and ethical AI, what it really matters. Here we can say, while artificial intelligence brings the power, it also brings the responsibility. Now, what are the key concerns are here? We have to take care of these key concerns. That is biasing. Here, when we are using the artificial intelligence machine learning, we can come across the different concerns. One of them is the bias or biasing. Here, what happens is artificial intelligence models must be trained on a diverse data to work equitably across all regions and user types. Because if a particular model is being designed and trained for a particular type of region, then obviously it will predict the things according to that particular region, which may or may not be applicable for the different regions or different user types. So obviously biasing should not take place over here. We have to train that AI models accordingly so that adaptability of that AI model will be there for different regions as well as for different user types. That is one thing. Second concern what we can say is the safety. Here, artificial intelligence based control systems must be explainable and verifiable, because irrespective of the past data, if the decisions are being taken by the artificial intelligence, there may occur certain safety concerns which we will prone for the security of that particular e-vehicles, and that has to be taken care of. So all possible safety precautions has to be taken care of while training the AI based models as well as machine learning based models. That is the second concern what we have. The third concern is the privacy. That means the user telemetry and the location data must be secured using the robust encryption and techniques like federated learning. Why? Because here the privacy concern is very important. If the data is being manipulated, then according to that data, the AI and ML predictions will go wrong. It will obviously make that particular system inefficient, and there may create certain issues. So that is one of the third concern what we can say is the privacy. And the fourth concern what we have as a responsibility of the AI is sustainability of artificial intelligence. Means what we can say, we must optimize the algorithms to minimize the training energy consumed during the model training. Means whatever energy consumption that has been taking place while training a particular model, that should be as low as possible. So these are the four concerns we have to take care of while implementing or training the artificial intelligence and machine learning models. So what we can say in simple words, that artificial intelligence systems must be transparent, they must be unbiased, they must be safe and secure, as well as they must be privacy preserving. Ethical considerations ensures the trust, fairness and sustainability. Responsible artificial intelligence is a foundational to long-term innovative innovations and public acceptance. So one quote I could say here is that artificial intelligence that doesn't respect the ethics cannot drive sustainable innovation. So taking into concern this particular thing, we have to take the further steps. So as a future research directions, we can say there are certain emerging frontiers for faculties and PhD scholars. The first thing is machine learning for solid state battery modeling, artificial intelligence for EV cybersecurity, edge artificial intelligence for real-time inference on vehicles, multi-agent coordination for fleet level optimization, artificial intelligence for life cycle assessment and sustainable matrices. So these are certain things where we can encourage the different faculties as well as students to, or the PhD scholars, to work on and obviously do a certain research. One thing what we can say is we can encourage the faculty to publish in IEEE transactions on transportation, electrification, nature energy, and elsewhere journals of cleaner production, etc. Okay, so that is what the concern we have to take care of before actually implementing or collaborating AI, ML, and EV. Moving further, as a conclusion and a call of action, let's wrap up with a message of purpose. Here, I would like to say that we are not just designing the machines, we are engineering the intelligent ecosystems. So, a quote what we can say is sustainability is not a buzzword, it's an engineering challenge. And further, one more thing what I would like to say here is artificial intelligence is not replacing the engineers, but it is empowering them. So, as a concern, we can finally conclude that sustainability is an engineering responsibility and artificial intelligence is an empowering tool. Educators must shape the engineers capable of designing the intelligent, ethical, and sustainable mobility ecosystems. We, as the educators and researchers of faculty, are responsible for shaping the engineers who can design not just efficient machines but the intelligent ecosystems. So, I could like to say here to all the participants as a faculty, we as a faculty are responsible for all further things. So, let's educate, innovate, and demonstrate together in collaboration with each other. So, with that particular word, I conclude here and I would like to say thank you to each one of you, and I look forward to your thoughts, collaborations, and future partnerships. So, with that, I conclude my session. Thank you for patience listening. Thank you very much. Dear participants, you can raise your hand if you have any particular queries or discussions to be done, and I will unmute them. Or else you can put your queries in the chat box also. Okay, Mr. Kalpesh is there. If you are able to unmute, you can please unmute. Mr. Kalpesh, you have raised your hand. That's why. Else you can put your queries in the chat box also. Okay. Dr. V. Jayashree madam, you have any question? Dr. V. Jayashree madam, you can unmute yourself and you can ask the question. Okay, there's a question in the chat box. I would like to answer that. Okay, Dr. V. Jayashree ma'am is asking, are there any smart campuses in India? Yes, accordingly, we have one smart campus which has been there in India, that is IIT Varanasi, which has used the battery operated electric cars within the campus, which is a smart mobility initiative in their campus. And one more thing is that BNMIT is one of the example where zero emission EV charging stations are used to support the EV use in the campus itself. So these are two examples are there, IIT Varanasi and BNMIT.
So in chat box, one of the question is there, sir.
Yes.
Other than battery optimization, where can you use ML in EVs?
Okay, so as discussed in my presentation, not only the battery optimization, but in all the concerns of the EV, means all the fields of the EV, that means in powertrain, as well as controller and motor, everywhere we can use this AI and artificial intelligence, because each and every part can be studied with their actual operations as a part of a history, and that data sets will help to be will be acted as a trainer for that particular AI models, and we can predict the operations of all these things. And for motor, controller, BMS, everywhere we can take a help of this AI/ML. I have
Good evening,
allowed
sir.
the participants to unmute themselves. They can unmute and ask the questions.
Good evening, sir.
Yes, please.
Sir, actually in controller, how can we use ML, sir? Actually, whether we have data sets are available for like controllers?
Okay, actually the feedbacks can be taken from the various different sensors. Okay, and how
Okay.
these sensors can be sensors acts for different types of structures, means whatever life cycle of that particular vehicle is there, accordingly the sensors how they act and what kind of signals are being provided from the sensors, that can be used for the prediction purpose, and we can use it for further implementation. Means sensors data whatever are there, that we can use further.
Like a closed loop control, sir?
Yes, you can say in that manner.
Okay, okay, sir. But we cannot, but the machine learning is actually training the data set only, sir.
Right,
So
right. Here what will happen, here the sensors signals will be taken into consideration for the further predictions.
Okay,
that
sir.
can
Okay.
be that can be implemented over here.
Okay, sir. But whether data sets are available for like controllers and all, sir?
No, we have to look on that particular matter. I'm not sure about that.
Okay, sir.
Okay.
Thank you, sir.
Participants can unmute their mics directly and ask the questions. I have enabled the mic for all the participants. Check if you can unmute and ask the questions. Yes, Professor Kalim. Professor Kalim, your mic is unmuted.
Just I want to ask, sir, For particular operation of electric vehicle, how these sensors can be interfaced?
For a, okay. Actually, sir, here whatever things are there, in case of in the presentation also I have discussed, when we are going to have the different data that is coming, or the sensors, whatever signals are going to give, we can forecast for what type of vehicle pattern, what kind of signals that are being taken from the sensors, that can be studied accordingly, and we can predict for the further things. Means, as I said, one of the thing is maintenance, predictive maintenance, whatever is there. If suppose a particular failure is going to take place, that also can be predicted with that particular modeling, and it will help in overall life cycle of that particular EV.
Okay, okay. Means again, one query is like that, sir. In machine learning, also we are requiring some previous data sets. So it is
Right.
necessary in this regarding, sir.
Yes, yes, yes. Actually, we can
Yes,
just
yes.
that is what we can say here.
Yeah, yeah.
We can take a history of for which kind of cycle or pattern, how the sensors are being giving the signals, and that can be studied for the further improvisation.
Okay, okay, okay.
That can be done.
Okay, sir. Thank you, sir.
Okay, fine. Thank you.
Participant, any queries? Or proceed to other session?
If there are any queries, you can just unmute your mic and post your queries.
Okay, sir. Thank you. Thank you
Okay, fine.
for
Thank you.
your valuable knowledge on the topic Smart Mobility Revolution, Role of AI and ML in Sustainable Electric Vehicles. We will stop here first session. Now we will have 10 minutes break, and then we will start our second session. Today's second session. We'll start sharp at 7:45. Please stay connected, all the
Okay,
participants.
ma'am.